Let's take a look at an example that shows a different style of translation for our sine and cosine function. We see here in this example that this looks very familiar to our previous examples. We have an outside function, which would be a -2, the inside function, which is the 3x. And what is different is that we have a 2 that is connected to it. Actually, it's a positive 2 being added onto it. Well, we want to work with this function very similar to what we have in the past, except when I have a function on the outside, this tells me that my graph of the sine or cosine function is either going to go up or down depending on the value of this number. Here, since this is positive, I'm going to graph this function, and then when I'm done, every point on the function is going to move up 2. If it was negative, it would move down. So I follow the same procedure until I get to this point. So let's start with the amplitude. The amplitude is the value of this constant in front of my function, which is the -2. The absolute value of the -2 is 2. The period is still going to be 2 pi divided by b. In this case, my b is 3. Therefore, the period is 2 pi over 3. Quarter point is found the same way as we have in the past, which is to take my period times 1/4, which is going to be 2 pi over 12 or pi over 6. Now I'm going to graph the function y equals a -2 sine 3x. Y-axis, my altitude is going to be 2. And my quarter point, I'm going to count by pi over 6. And 4 pi over 6 is 2/3, which is our period. I'm going to use the sine function, so that starts at the origin at 0. But what I notice is that my amplitude is 2, but the function in front of my sine function is negative, so I'm going to go down 2 instead of up, and then follow the process of 0, +2, and 0, finishing with what I started with. Now I just connect with a smooth curve. Now I'm going to handle the 2 out in front of my function, and that means that every point on my graph is going to move up 2 because it's positive. So at 0, that moves up 2. At -2, that moves to 0. At 0, that moves up to 2. This point is already at 2, so it's got to move up 2 more levels, which makes that to 4. And this is at 0, and that moves to 2. Then I'm just going to create a smooth curve to complete the function. Let's verify our solution using a calculator. I have the function graphed. My window, I'm going to set up as usual, except for the bottom part where I have a y min and y max. I actually extended that by 2 units or 3 units on each end because of the translation of the vertical movement of 2. So you can see I made that a -4 and 5. Then I graphed, and then I'm going to find a calculation value to verify a point. I'm going to use pi 6, and hopefully I get 0, and I do. The next function, y equals a -1 + 2 sine 4x plus pi, gets a little bit more complex. Here we have a term outside of our function that is a -1. That means I'm going to have a vertical shift. My interior function, the variable, has a constant other than a +1, so I need to factor to determine the period and also to determine the phase shift, and then I also have an amplitude to deal with. So we have multiple things going on. Remember, when this is not a constant of a +1, I need to factor first. So let's get our function in the right order. So y equals a -1 + 2 sine, and since this is a +4, I'm going to factor out that +4, and that will give me x plus pi over 4. Recall I can distribute to check my solution. 4 times x is going to give me 4x, and 4 times pi over 4 gives me pi. So this is correct. Now I can follow the same process as I have in the previous examples. My amplitude, the constant in front of my sign, which is going to be the absolute value of 2, so it's 2. The period is going to be 2 pi divided by b. Here, b is 4. Therefore, my period is pi over 2. My quarter point is going to be my period times 1/4. Therefore, that's going to give me pi over 8. Now, what we want to do is to determine my phase shift. Remember, to do that, I take my interior function, which is x plus pi over 4, and set it equal to 0, and then solve for x. Therefore, that gives me a negative pi over 4. So my phase shift is going to be to the left. Let's start graphing the function. My y-axis, my x-axis, amplitude of 2, but I have a vertical shift of 1. So I'll make that a little bit bigger. My period is pi over 8. I'm going to count by 8s until I get to pi over 2, because that's my period. So pi over 8. Two pi over 8. 3 pi over 8. And 4 pi over 8. And that is going to be pi over 2, which is my period. All right, let's graph the function y2 sine x. And we already have that set up with our quarter points. So remember, the sine function starts at 0. And I have an amplitude of 2, so we go to 2 for the next quarter point. And then to 0. And then down to a negative 2. And back to 0. And then we complete with a smooth curve. Now, what I want to do is to do a phase shift and a vertical translation all at the same time. So let's take care of the phase shift. Remember, the phase shift is going to be each quarter point moved to the left by the amount of pi fourths. I've already generated the mathematics behind this, that 0 minus pi fourths is going to give me a negative pi fourths. Pi eighths minus 2 pi eighths, or pi fourths, is going to give me a negative pi eighths. 2 pi eighths minus pi eighths is going to be 0. And then we have 3 pi eighths minus 2 pi eighths, which is going to give me a pi eighths. And 4 pi eighths minus 2 pi eighths is going to give me 2 pi eighths. Now I have my phase shift points on my x-axis. And what I want to do is to do a phase shift with my points and also a vertical translation down by 1. So here I'm at 0. This moves over to a negative pi fourths, but it's not at 0. It now goes down to 1. Next, I have a value at pi eighths at a positive 2. It goes to a negative pi eighths, but down 1. Next, 2 pi eighths goes to 0, but it's going to move down 1. Next, 3 pi eighths goes to pi over 8, and it goes down a value of 1. And 4 pi eighths goes to 2 pi eighths by a value of 1 down. So now I complete that smooth curve. And that is my new function, which is y equals a negative 1 plus 2 sine 4x plus pi. Let's verify using a calculator. Notice I've entered the function negative 1 plus 2 sine 4x plus pi. My window, the period is a negative pi over 2 for x min, for max, pi over 2. My scale is pi over 8. And my y min and y max, I've gone a little higher and lower to take into account the translation of 1. And then I graph the function, and I'm going to calculate a value to see if I'm correct. I'm going to choose, let's say, pi over 8, second, pi divided by 8, and I should get a value of -3 to match my graph. Therefore, I am correct.